We are in section 10.3. Now we're talking about the unit circle. So we need to know, before we talk about the unit circle itself, we need to know a little bit of terminology that we're going to use when we talk about the unit circle. So one idea that we're going to work with is the angle of rotation. And the angle of rotation, it's a really easy idea, is how far do we rotate counterclockwise from the x-axis? I'm going to put CCW for counterclockwise. So if we have an angle, we've been talking about angles, so what we're interested in is if we have our x and y axis here, and our angle is like so. Oops. And this is x and this is y, and we're rotating counterclockwise from the x-axis, and that's our angle. So theta is the angle of rotation. So we start here at the x-axis and we count how many degrees we rotate around, and we're going counterclockwise. So I just want to we'll just draw a bunch of pictures and talk about the angle of rotation for each of our little pictures. So if this is these are our axes, we're just going to do them really small because we don't need a really big picture for this. And our angle is here. Our angle of rotation is that one. And we could say that one's 45 degrees. So we're saying that angle of rotation is 45 degrees. So all we're talking about is this angle. If we rotate past the y-axis, then our angle of rotation is just bigger than 90 degrees. So if we go out to here, we're measuring from the x-axis, and we could say that angle is 120 degrees. So it's bigger than 90 degrees, but it's less than 180. We can also go further than the x-axis on this side. So if we draw our picture here, and our angle is down here, and we've rotated all the way around from here, this angle of rotation we could say is 225 degrees, so more than 180. And we can keep rotating around past the y-axis down here. If we rotate further around, then we end up with still a bigger angle of rotation. So we've rotated all the way around to there now. And we start here. So we're going clear around to there. And we could say that angle of rotation is, say, 330 degrees. We can keep rotating around. We don't have to stop at 360 degrees. We can keep going. So if we go even further, so we keep rotating around this way, we could have an angle that's bigger than 360 degrees. So if I rotate clear around to here, and I've gone around one whole time, and the way you'll know is they'll draw the arrow like this, and that tells us we've spiraled all the way around once. we could say that angle of rotation is 405 degrees. So we started at the x-axis, went all the way around, and then went a little further. And we can keep going around as many times as we want. We just keep counting how many degrees we go from the x-axis. We can also have a negative angle of rotation. So let's show how we can have a negative angle of rotation. So if we've rotated around to here, we could write this as a positive angle of rotation here. And let's say that's 315 degrees. We could also call this a negative angle of rotation, going clockwise from the x-axis. And the way we figure that angle out is 360 minus 315 degrees is 45 degrees. So this angle of rotation would be negative 45 degrees. Gone 45 degrees in the opposite direction. And that's the same as saying 315 degrees in the positive direction. So if we're going negative, we go clockwise. Positive is counterclockwise. And the way you know that you've gone around more than once is your arrow will tell you you've rotated around more than once, or somehow the problem will tell you. Questions on angle of rotation? All right, so we're going to use the angle of rotation to help us out with our angles on the unit circle. And what we mean by unit circle is a circle. Its center is 0, 0. And its radius is 1. That's what unit means. Unit means 1. And this helps us out with our trig ratios. So let's take a look at why that's the case. So here's my circle. Oops, that's not a circle. So here's my circle. And I'm going to put my center in here. And we'll draw in a set of axes. So that's our x, and this is our y. And our center is at 0, 0. And anywhere, any point that I put on the circle, our radius is going to be 1. So let's draw in a radius. And we'll call this point, it has coordinates x and y. And the radius equals 1. Now what we're going to do to use the unit circle to help us out with trigonometry is we're going to turn this into a triangle. And we did this a little bit last chapter when we were working with circles. So I'm going to turn this into a triangle and make the sides dotted. So I'm going to do it like so. And like so. And we'll say this is a 90-degree angle. Now let's label the sides of this right triangle. Is the radius the opposite, the adjacent, or the hypotenuse if we're talking about that angle? The radius is the hypotenuse. So the hypotenuse is 1. Anywhere on the unit circle, the hypotenuse is 1. This side, is this side the opposite, the adjacent, or the hypotenuse? And we're talking about this angle. We're across the triangle, so that's opposite. And this side is our adjacent side. So let's write the sine and the cosine of our angle here. So the sine of theta equals the opposite over the hypotenuse, or just the opposite. The hypotenuse is always 1. And the cosine of theta is the adjacent over the hypotenuse, or the adjacent over 1. So on the unit circle, the sine of theta is just the opposite side. And the cosine of theta is the adjacent side. So we end up without fractions because our radius is 1. Well, the reason this helps us out is the adjacent side is the x-coordinate of our point. It tells me how far I go over to get to this point. And the opposite side is the y-coordinate of the point. It tells me how far up I go to get to the point. So on the unit circle, the reason that we use the unit circle is on the unit circle, and this is one of our big ideas from this chapter, is that the sine of theta equals the y-coordinate and the cosine of theta equals the x-coordinate. So if we have some point xy on the unit circle, we can figure out the x-coordinate by taking the cosine of the angle, and we find the y-coordinate by taking the sine of the angle. And the reason we can do that is our radius, so our hypotenuse, is always 1. And this simplifies calculations when we're dealing with our trig ratios by a lot. And when you go further in math, you'll talk about the unit circle a little bit more in Alg 2, and in pre-calc we work with the unit circle a lot. And if you go to calculus, you'd use a unit circle all the time in calculus. All right, so any questions before we move on? So this idea is one of our important ideas about the unit circle, that y-coordinate is the sine of the angle and the x-coordinate is the cosine of the angle. So let's take a look at what kind of problems you might be asked to do knowing this. So in both of these examples, we want to find the x and y coordinates of the point on the unit circle. So for our first problem, we'll draw in our circle. Here's our circle. Let's put in our center. Draw in our axes. Undo that. So here's our x-axis. Here's our y-axis. And our point is here at the end of this radius. And the point is at xy, our coordinates. And this angle is 35 degrees. So we're on the unit circle. It tells us this is a unit circle. We want to find the x and the y coordinates. The x coordinate is just the cosine of the angle. So x equals a cosine of 35. We plug that into our calculator, and I get 0.82. Y coordinate is just the sine of our angle. Sine of 35 degrees, so y equals plug sine of 35 into our calculator, and we get 0.57. So our point is the 0.82 for the x and 0.57 for the y. And that's all we have to do. The sine gives us the y coordinate, the cosine gives us the x coordinate, because we're on the unit circle. Questions on that example? All right, let's look at another one. So here's our circle for this one. Mark our center here. And our axes. And we'll draw in a radius down here this time. So here's our point. And this time our angle, we're going from here, counterclockwise. Our angle of rotation is 230 degrees. And we want the x and the y coordinates. So x is just the cosine of 230 degrees. Plug that into our calculator, and we get negative 0.64. And the y is the sine of 230 degrees. Plug that into our calculator, and we get negative 0.766. So our point is negative 0.64 for the x and negative 0.766 for the y. And both of them are negative, which makes sense down here in the third quadrant. Questions on that example? So x coordinate, cosine of the angle, y coordinate, sine of the angle, as long as we're on the unit circle. All right. Let's look at another thing that we need to keep track of with the unit circle. We can have more than one angle that has a particular sine and more than one angle that has a particular cosine. So when we plug a number into our calculator and do the inverse sine or the inverse cosine to get our answer, our calculator tells us one answer, but there are actually two answers. And let's see why that works. So we're talking about angles with the same sine or cosine. So let's look at a unit circle. So here's our unit circle, and I'm going to draw in my center, and we'll draw in a set of axes just like we did before. So here's my x, and here's my y, and I'm going to put 2 points. I'm going to put 2 points on my unit circle that have the same y value. So I'm going to put a point here at P, and I'm going to go over here and put a point here, and we'll call this Q. And we're going to draw in a radius for each one of these. And I'm going to call this angle A, and this angle B. Now I'm going to draw in a couple of dotted lines here for the y component, the y part of the y coordinate of my point. So I'm going to draw that line down there, and I'm going to draw this line down here. Like so. So I'm going up the same distance to get to point P and point Q. So P and Q have the same y coordinate. So I go up the same distance to get to P and to Q. Well, on the unit circle, the sine of the angle gives me my y coordinate. So this tells me that the sine of A equals the sine of B. So both of these angles, A and B, have the same sine ratio, because on the unit circle their y values are the same. So these are two angles that have the same sine. Now let's look at the cosine. We're going to draw another unit circle. Here's our circle for this one. Put our center in here. Draw in our axes. Oops. So there's our x and our y axes. And we'll have to make the center nice and big here so it works. And now I'm going to put 2 points P and Q that have the same x coordinate. There's point P. And there's point Q. So let's draw in a radius for each of these. And our angles here, I'm going to call this angle up to point P is A, and the angle all the way around here to point Q is B. Now I'm going to connect P and Q with a vertical line, like so. And this is my x coordinate. So for P and Q, I'm going over the same distance to get my x coordinate. I go over this distance to get to P, and I go over this distance x to get to Q. So P and Q have the same x coordinate. So that tells me on the unit circle that the cosine gives me my x coordinate. So cosine A equals cosine B. So A and B are two angles that have the same cosine. Well, this tells me why it works. Now we need to know how we figure out those angles. So let's give the rules for angles that have the same sine and cosine. Any questions on this part? All right, so our rules. Two angles. With the same sine are theta and 180 degrees minus theta. If we're trying to find an angle and we use the inverse sine to get my angle, my calculator is only going to tell me one angle. It's going to tell me theta. Another angle with this, another possibility that has the same sine is 180 degrees minus theta. Two angles with the same cosine. Are theta and 360 degrees minus theta. So if we need to find an angle and we have the cosine ratio and we use inverse cosine, our calculator is going to give us one answer. Another possible answer is 360 degrees minus the angle. So both of those angles are going to have the same cosine. So that's our second big idea from the unit circle. First is the x-coordinate is the cosine, the y-coordinate is the sine. Second is that we have two angles that have the same sine ratio, and we have two angles that have the same cosine ratio. Questions before we look at a couple of examples of this? All right. So your problems, the problems with these, with this idea, are going to say that the sine of theta is 0.682. Find two possible values of theta. So we have the sine ratio, and we need to find the angle. So what do we use to find the angle if we have the sine ratio? Sine minus 1. So we do the inverse sine. So we're going to use, we're looking for an angle, so we use an inverse. So we do sine minus 1. So I'm going to say that theta is the inverse sine of 0.682. We plug that into my calculator. Clear that. We're going to do inverse sine of 0.682. And we get about 43 degrees. So let's go back to our problem. So theta is about 43 degrees. Our other possible value is 180 degrees minus theta. 180 degrees minus 43 degrees is 137 degrees. 180 minus 43 is positive 137. And the way we can check our work, let's find the sine of 137. We're saying that the sine of these two angles is the same. So we're going to go back and calculate the sine of 137. I get 0.682. And we said that the sine of our angle was 0.682. So the sine of 43 and the sine of 137 are both 0.682. Questions on that example? So let's look at a cosine example. We have the cosine of theta is negative 0.891. Find two possible values for theta. So this time we have the cosine ratio, and we want the angle. So what do we have to do to find our angle? We know the cosine and we want the angle. What do we use? The opposite of cosine. And what do we call that? Cosine minus 1, or inverse cosine. So we're going to use a cosine minus 1. So we're going to say that theta is the inverse cosine of negative 0.891. Plug that into my calculator. Inverse cosine of negative 0.891. And I get about 153 degrees. So theta is about 153 degrees. The other possible value is 360 degrees minus 153 degrees. That equals 207 degrees. And the way we're going to check is we're going to find the cosine of 207, and it should come out to negative 0.891. So let's do the cosine of, what was our angle? 207. And we get negative 0.891. So the cosine of 153 and the cosine of 207 degrees are both negative 0.891. Any questions on that? Okay.